Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is SignalR Applicability to the Messaging Patterns Required by Capital Markets Applications. Our guest speakers today are Manoj Mittal, Senior Microsoft Technology Specialist, Sapient Global Markets, and Manish Agarwal, Director Technology, Sapient Global Markets. With over 12 years of software architecture design, application integration, and development experience in finance, insurance, and retail domains, Manoj is adept in Microsoft technologies like .NET, X.X, SharePoint, and various enterprise integration application patterns and ORM frameworks, and is an expert in designing and developing SOA-oriented, component-oriented web and thick client applications. In his current assignment, Manoj is providing technical leadership and expertise to a globally distributed team for designing and developing a complex equity trading platform using WPF technology. Manish has over 14 years of extensive software industry experience, successfully leading large teams to design and implement complex business-critical information technology solutions. Manish is currently leading the Microsoft practice team in Sapient's Global Markets business unit. In his last 11 years at Sapient, Manish has worked for various clients in the automotive, healthcare, finance, and insurance industries. So without further delay, I introduce you all to our guest speakers. Over to you, Manish.
Thank you. Hello, everyone. Let's quickly, with the introductions over, let's quickly jump into our session for today. We will talk about what SignalR is and how it is applicable to the capital markets as a domain, the applications that we develop for capital markets. Here's the agenda. We will first look at which messaging patterns we're talking about, what do we mean by push-based messaging patterns, and so on. We'll look at traditional ways of doing those, implementing those patterns. So it's not as if those patterns could not be implemented traditionally, and we have been implementing them. Then we look at what the problems were in the traditional ways and how SignalR helps solve them. And finally, we will spend the majority of this session looking at an actual application and some source code and how we developed it. So let's look at what the messaging patterns, which messaging patterns we're talking about here. So typical capital markets applications deal with a lot of real-time data. There is data from stock markets, from order management systems, from news applications, news feeds, and so on. And all of this information needs to be, given to the traders and portfolio managers and the users who basically need use all this data in real time. So the typical push-based messaging pattern in any client-server kind of a scenario would be something like a publish-subscribe, for example. A publish-subscribe could be that your application subscribes to certain stock symbols, and the server publishes the current market prices for those symbols. Or it could be a broadcast where the server is broadcasting the current news feeds, and whoever wants to listen basically looks at it and so on. Or it could be a multicast where the server needs to push out an information, but it is meant for a specific set of audience. So maybe there is a particular order which is relevant to a particular desk. All the traders on a particular desk need to look at that order, and therefore it is a multicast scenario where information is pushed by the server to a certain set of audience. So keep these scenarios in mind while we do the rest of the discussions and these will help us guide through some of the decisions that we make, and some of the architecture issues that we look at. Looking at how we used to do it traditionally. Now, in thick client applications, it was it is typically easy, where you have a queuing infrastructure or message-oriented middleware, and your thick clients can connect over TCP to that kind of infrastructure. But what if your applications were web-based? In a web-based scenario, these push messaging patterns were significantly harder to implement, or rather are significantly harder to implement. So some of the ways in which you would do this in a web application would be by using a polling mechanism, using a timer, or using long poll. So if any of you have used the WCF duplex communication mechanism, that uses a long poll in the background. A long poll is essentially something like your client makes a request, and the request never times out, and so the connection remains open, and whenever the web server has some data to send, it responds to that request, and the client just turns around and makes another long-standing request. So that way, the client always has an open connection, or the server always has an open connection to the client. So that's how long poll used to be implemented. So these were some of the traditional ways. In the new HTML5 standard, some of the there came along some new mechanisms to do the same kind of thing. There's something called server-side events, which are supported by all browsers other than IE, almost all browsers other than IE. And HTML5 also brought a standard called WebSockets. WebSockets are essentially a mechanism to implement, to get socket kind of connections over the web. So you use HTTP to do the handshake, and eventually set up a TCP-based connection over, between the client and the server. And this would give you, a similar mechanism of transferring data as a regular socket would have given you in a LAN environment, so to say. Having looked at all of these different, traditional and new mechanisms, the big problem with all of these is that they need a lot of infrastructure support in terms of being supported by both the client and the server. So, for example, server-side events are not supported in IE. Forever frames are supported only in IE and by nobody else. WebSockets are supported only by the new browsers and the new servers. But even if you had a client and a server both supporting WebSockets, all the intermediate proxy layers should also support it. So, the bottom line is that if you wanted to use these technologies, you would have to figure out the lowest common denominator which would be supported in your scenario, and then code to that. Or you would need, as a developer, you will need to write if-else kind of logic where you determine the current state of the client and the server and all the proxies, and then determine which mechanism I can use, and then write code against that, and then write, have your logic run against that mechanism, which obviously is hard to do. That is where the need for, or the inspiration for SignalR comes in. So what is SignalR? SignalR is a layer of abstraction over and above the basic, the various different technology, the various different transport layer and protocol layer, application layer protocols. So the way the 4 or 5 different mechanisms of doing push data transfer from the server to the client we looked at are all supported by SignalR. SignalR basically gives you that if-else logic that I was talking about. It gives you the negotiation mechanism, and it is a layer of abstraction over all of them. And you only write code against SignalR, and based on the capabilities of the server and the client, the SignalR logic will automatically choose the best possible option for you. So if the server and client both support WebSockets and all the intermediate layers are also supporting, the proxy layer is also supporting WebSockets, then you will use WebSockets. If client and server only support long polling, then that is what you will use. But from a developer's perspective, it is completely abstracted out. It is transparent to you. You don't need to worry about it. Let's look at what SignalR is made up of. It is, think of it as the layers described in this diagram. At the bottom is the transport layer, which is the physical connection between the client and the server. Above that is an abstraction called as a persistent connection, which SignalR builds. Persistent connection essentially is the abstraction I have been talking about so far. It is this is the layer where the determination of which protocol to use, whether to use long polling or WebSockets or something else, that decision is done by this layer. Okay. So from a developer's perspective, we only deal with persistent connections. On top of persistent connections has been built a concept of a hub. Now, what a hub is, essentially it gives you the an RPC, a remote procedure call kind of paradigm on top of a connection based. So a connection is typically used for a request response kind of a paradigm, right? You open a connection, you ask for some data, and you get some response back. Hubs is not related to a request response. Hubs gives you an RPC kind of a paradigm. So the client calls a method on the server, and the server calls back a method on the client whenever it needs to send data back. And we will look at some source code, a lot of source code for that matter, as we go. But keep in mind that if, most of the time you will only be dealing with hubs. Hubs give you abstractions like groups and group management and so on. Another important thing when dealing with push-based or when dealing with a persistent connection-based mechanism is that you need to think about concurrency differently from a web application. So your scaling needs are very different when you have open connections being maintained for clients while they may not even be currently being used. So in a typical HTTP application or a web application, there's a request that you process and send back, and and then you can process the next request. While if you have a persistent connection, that you need to keep that connection open, and therefore your scaling needs will be very different, and you need to think of your application also very differently. So the way SignalR applications would scale out is using the concept of a backplane. So this is the other concept we will not talk a lot about here because for now we will basically be dealing with the other concepts that we talked about, and how the various messaging patterns are implemented. But keep this in mind, because in a real world application, you will also need to think about scaling the application for your needs. So so SignalR applications need what is the concept of a backplane. What a backplane is essentially a way for the various SignalR servers to share connection. So for example, I'll give you an example. So I, as a client, subscribe to a stock ticker, a share price, and I'm connected to server 1. And there is another client which is connected to server 2, which also subscribes to the same stock ticker. Now, when server 1 gets the price for that stock ticker, it will send it to. It can only send it to the client that it is connected to, right? Now that stock ticker price will also need to be propagated to server 2, so that can connect, send the same data to the clients connected to it, and which is where the concept of a backplane comes in. Backplane is implemented, is implemented using the provider pattern, and there are several several implementations that are currently available for it. But for now, it suffices to say that it is a mechanism for SignalR applications to be able to scale out. From here on, let's actually jump into a real application, and I will hand it over to Manoj to demo for us a real application which implements some of the messaging patterns that we looked at, and then we can look at some of the source code that was used to develop those applications.
Thanks, Manish. All right, guys. So let's look at the demo of how we have implemented broadcast and pub sub model in this application. So just to give you an overview of an application, this is a typical order management system and a stock ticker kind of application. So the idea here is that a user subscribe to a symbol, and only that user will get real-time prices for that subscribed symbol. So in this example here, I have 3 browsers open. Even though if I subscribe, so let's say in my Firefox client, if I subscribe for a symbol Yahoo, click on subscribe, the Yahoo gets added to my live stock table here, whereas my IE client and my Chrome client won't get that Yahoo subscription, because that's a typical pub sub scenario where a user asks for a subscription. The security gets added to that particular client. Now, if we click on open market, we see the real-time prices for these added symbols, and you see that only the Firefox client will get a price update for Yahoo, whereas IE client and the Chrome client won't get a subscription for Yahoo. Now, if we try to add, let's say, Yahoo again for my Chrome client here, so my Chrome client also gets a real-time price update for Yahoo. My Firefox client gets a update for Yahoo, whereas my IE client, since it has no subscription for Yahoo, it won't get those price updates. This is a typical use case for our pub sub model, where clients subscribe for a particular stock, and they will get the price update based upon the subscription. Another use case which we have and we talked about is the broadcast mechanism. So the order management system is primarily used for the broadcasting mechanism. Here, there are various use cases, like you can create an order. So once you create an order, that order will get displayed to all the traders, right? Similarly, when you execute an order, the order execution will get displayed to all the traders simultaneously. When somebody edits an order, that addition or the updated values get pushed to all the clients. So let's look at the create order thing first. So in my Firefox client, if I add an order of Yahoo with side sell trader, let's say MKM, with a quantity of 1,000 and a price of $250, I do add. So you see that all the clients will get Yahoo as order added to them. If I execute, let's say edit, let's do the edit first. Let's edit the special instruction and quantity. So all the updates for the edit will flow to all the clients. If we try to execute this order, all the clients will simultaneously get the update for an executed order. So this is a typical use case for a broadcast, where all the connected clients will get the updates if one of the client will take any of the action on an order or edit any of the orders. Now, from a code perspective, let's look at how we have implemented first the pub/sub model and then the broadcast mechanism. Now, in this, let's look at first the project structure. What are the various components of SignalR? When we start thinking about SignalR, how do we integrate SignalR on the server side or on the client side? Server side has two pieces, right? It has a server side component and it has a client side component. From a server side perspective, you need to add a reference to Microsoft.ASP.NET.SignalR.code. So basically what you have to do is to include a nugget package, which is a SignalR. So if you go to tools, options, and do the package library manager and add a SignalR from there, it automatically adds the SignalR.core, SignalR.owin, and SignalR.system.web on the server side. And on the client side, it will add a jQuery based client, which is jQuery.signalr.1.3.js and jQuery.signalr.1.3.min.js. This is the client side component for SignalR. So SignalR client side component is one JavaScript based library, and there is a .NET based client as well, which you can use in your WPF application or in a WinForm application. So that's the code. That's the structural part of a SignalR. Now let's look at how we have implemented a pub/sub model using a stock ticker example here. So on our server side, first of all, the important concept here is to define a hub, a stock ticker hub. So first, your hub class need to inherit from there's a class called SignalR.hub. Look at this Microsoft.ASP.NET.SignalR.hub. So your class need to inherit from a hub class, and you have to provide the hub name. In this case, we have provided a hub name as ticker. Now there is so this hub is basically, as Manish mentioned, that this is primarily a RPC based mechanism. All you are doing here is defining some methods like get all stocks, get market state, open market, close market, subscribe. All these are basically methods on a server side that you call from the client side. So all these methods are basically a gateway that you call into. And then the real implementation is in class called stock ticker controller, which is basically an independent class that takes care of all the logic of basically subscribing the stock prices and basically publishing those stock prices. So let's look at an example here. So first look at the subscribe. So basically when we call subscribe from a client side, it calls a server side method called subscribe, and then we call ticker.subscribe method here. So what the ticker.subscribe method is a stock ticker controller .subscribe method. Here what we do is basically do a logic of adding it to the mapping collection and basically creating a stock, and then we define and add that particular symbol to the groups collection. So groups is another concept which hubs provide basically. So groups are, think about groups like an entity or something like where you want to publish a data to a certain set of users. So basically you maintain a group by symbol and you add the number of connection IDs to that group. So if you have a symbol like Yahoo, and Yahoo has been subscribed by 2 or 3 clients, so you create a group by the name of Yahoo and add those 2 or 3 client IDs with the Yahoo symbol. And when you try to publish that, updated price, you publish a price update to a symbol. So all the clients who are basically registered to that particular symbol will get an update. In this case here, in our example of publish stock subscription, if you look at it, what we do here is that clients.group, which is stock.symbol, and then update stock price. So client.group will give us a group for that particular symbol, and then we call a method update stock price, which gets called on a client side. So if you look at group, client.group, it is basically returning a dynamic type of object here. So the dynamic type of object says that this method will get evaluated at runtime, and the SignalR provides us a capability that this method will get called on the client side. So let's look at the client side implementation of subscribe method. So in our ticker.js, we have ticker.client.update stock price. So remember, on the server side, what we are doing is we are calling client.group.update stock price. So there is a definition of update stock price at the client side. So this method gets called whenever we, from a server side, we try to publish the stock prices, and here we try to update the stock prices on the JavaScript view model. If we have to call the server side script method, the way we do it is right. So look at this. So when we have to call from a client side, when we click on a subscribe button, we call ticker.server.subscribe. So this method, this call here, will call a subscribe method on a server side controller, on a server side hub. The stock ticker hub subscribe method will get called when we call ticker.server.subscribe. So this is a typical use case. This is a typical code for client to server communication using SignalR, a pub sub model. Now let's talk about the order management system, which is a broadcast mechanism. So in this stock ticker, we looked at a way of implementing hubs which are pure RPC based mechanisms. Like hub is the one who is communicating, who is trying to communicate between client and server. Right? Now there is another pattern for implementing hub, and which is web API based, which we have used in our order management application. So think about order management. Think about the order management application is like any other web API based application, right? It's a RESTful based system where you basically send a data to a server, basically post when you try to create an order. When you edit an order, you do a server-side put. When you publish an order or execute an order, you do a server-side put. So it's a web API based mechanism. It's a RESTful way of calling the server. Now, in order to implement a push-based mechanism, we have integrated a SignalR to it so that all the clients will get updates whenever any clients try to take any action on an order or try to add new order. So that's where the SignalR comes into picture. Otherwise, it's a plain web API based controller. So let's look at the order controller first. So order controller, if you look at it, it basically inherits from API controller with hub, which is again a class which we have implemented. API controller with hub is basically a normal controller which inherits from API controller, like in any MVC4 application, right? So we have an API controller, we inherit our controller with API controller. What's the role of this controller here? Is this controller manages the hub instantiation and maintains the instance of hub. Since we need this controller to notify all the clients as well whenever there is an action on an order, so it needs to maintain an instance of hub. That's what this controller is doing. If you look at the order hub, it's pretty simple. There's nothing, no line of code here. It's just a hub name. It inherits from a hub class, and it just exposes the hub with a hub name, which is in this case is the order. So unlike the stock ticker hub, which has lots of methods like close market, open market, and all those kind of things, which is a RPC based mechanism, this class is pretty simple. This is just a hub declaration, and your API controller will maintain the instance of this hub. Now our order controller, while creating an API controller with hub, it says that what kind of hub it needs to maintain. In this case, it says that it's an order hub it needs to maintain. Right. So on a server side, the code is pretty simple. When we try to add an order, we say, so it's like you guys already know that it's a web API based syntax. So verb, HTML verbs is what is being used. So any request that goes to the server automatically matches the HTML, HTTP verbs. So in this case, post add order will automatically, the post request will call this method called add order here, which tries to add an order to the system. And then after adding an order, it does call hub.client.all add order. Hub.client.all, what it does is saying that broadcast this order to all the clients. So see the difference here. So in a broadcast mechanism, you are saying hub.client.all, whereas in case of pub sub mechanism, you are saying client.group.stock_symbol.updated stock prices, right? So basically there is a mechanism at every level where you can specify whether you want to publish or notify a set of clients or to all the clients or do a specific client. So in this case we have said in the broadcast mechanism, we have said that hub.client.all add order. All is again is a dynamic object. It does a dynamic object, and add order again gets called on the client side. Right. Similarly, when we have a edit use case, which is an update order, it says a put request. So server side, since we have multiple put requests here, put update order, put allocate order, put place order, so we have to specify the action name like we do in web APIs anyways. You have to specify the action name for if we have more than one verb defined for a HTTP request, then we have to specify the action name. So in this case, we have said that the action name is update, and when after updating the order in the system, we again broadcast this update to all the clients. Similarly for allocation as well. We subscribe, or basically after marking the order as an allocated, we push the status to all the clients. Now let's look at from the client side, how does this get called? So we have an order.js basically, which talks about, before we jump into looking at how we call these various methods from a client side, one important thing which we should look at now is how we establish first a connection to the client, to the server, to SignalR server, and basically how does this entire connection mechanism work. So if you look at order.js, there's a dollar function, which obviously is a jQuery method of saying once all the scripts are loaded, then execute this function. Here we create an instance of first the view model, and then we specify $connection.order for order hub and $connection.ticker for our stock ticker hub. Then we specify, then after specifying the order, basically these are the client-side functions that get called from a server. Let's ignore them for now. What is important to know for now is $connection.hub.start. This will start the connection with both the hubs. So basically $connection.hub.start will actually initiate the connection with your server, with your hubs. And here in this case, so basically this is a jQuery based mechanism, so we basically specify once this starts is the asynchronous call. We say once it's done, then get all the from server, get all the stocks, and then once all that get stock is done, then add them to the stock ticker view model. Now let's look at how we are calling the server code from a order.js. Now when we try to add an order, we call send create method, which is basically here we are specifying, it's a normal jQuery based call. Here we are specifying $.ajax, giving the URL, which is like normal API/order is our controller, data to be sent, and then the type of the request is a post request. So we are sending this request to a client, to the server, and once the server gets this request, it adds the data. It post add request, right? So basically, in this case, we are not specifying add request anywhere because there is only one post, and it automatically matches with it. The system is smart enough, the web API is smart enough to match the HTTP verb post with the post keyword here, and it automatically calls the add order. And once it adds the order to the database, your order database, and then it calls the hub.client.all.add order. Add order is again a client-side function. Look at it here. Order hub.client.add order. This is a client-side function that gets called, and again here we add the order to the JavaScript view model. So it gets added here. Similarly, there is an update order on the client side, and then there is a Similarly, there is a client-side method for the allocation and execution. So that's pretty much all we have from the demo perspective. Now let's look at some of the nitty-gritties of under the covers. How does this all work, right? So remember Manish talks about the negotiation bit. How does SignalR supports 4 different types of protocols, which is long polling, server-side events, forever frames, and WebSocket. How does this all work, right? And how does client and server know that which transport to fall back to? So let's look at some of those details. If I start a fiddler, all right. So let's look at now, if I refresh my IE client, look at this. So the first bit is called SignalR.negotiate. This is where it says it creates a connection. Basically, it sends a connection token and the connection ID. It gets that in response basically, and it says whether it needs to try a WebSocket. In this case, it says false basically because in Win 7 there is no support for WebSockets, obviously. Then it fallbacks to long polling because you see all the request response that happen after that is using long polling. So you can see in the URL, basically SignalR./connect, when it's tried to connect, it says the transport is equal to long polling, and the connection, it sends the connection token whenever you have the connection token is the same connection token which you get from the negotiate call. So basically every web browser or client you connect to a server will call this negotiate, SignalR.negotiate. It gets the client ID and a connection token which it uses to do further communication with the server. If you look at that SignalR.send, in this basically send same which we use to get all the default stocks. Here it says that it is using the transport protocol as long polling and then uses the same connection token. Yeah. Now let's look at the Firefox. If I do a refresh on Firefox, again the Firefox calls a negotiate method. Here also it gets in the response it gets a connection token and a connection ID. It says that try WebSocket is equal to false because obviously there is no WebSocket support. Now, but the transport protocol here is a server-sent event. As Manish mentioned that Firefox supports a server-sent event, so the SignalR is smart enough to fall back to the server-sent event. So from a programmer or a developer perspective, now we don't have to actually care about here whether I am coding against the server-side event or my server or a client supports server-side event, or whether it supports a long polling or whether it supports a WebSocket. All I need to care about is code against my SignalR library. Similarly, if I do a refresh on my Chrome client, My Chrome client also uses a server sent event in this case. Yeah. So the important thing here to note, there's a sequence in which this fallback mechanism works. First, it tries to upgrade itself. It tries to use a WebSocket. If it did not find a WebSocket mechanism, in this case, we saw that it says the try WebSocket is false. Then it fallbacks to server sent events. And if a browser does not support server sent events, as I does not support server sent event, it try to fall back to forever frames. So our I client tried to connect using forever frames, but then it seems like there is some issue because I'm running with i9 compatibility mode. There's some issue with forever frames, so it uses the long pulling mechanism. That's the last fallback option. That's pretty much it from a demo perspective.
So, to conclude, we looked at some of the messaging patterns that a typical push application, a typical application which deals with real-time data which needs to be pushed to the client would need. We saw how they were implemented traditionally. We saw how how HTML5 recommends we do them, and then we saw why it is more beneficial to actually use SignalR instead of using any one of those different mechanisms, because SignalR basically negotiates based on the currently connected client and the current state of the server. It negotiates the appropriate mechanism and makes it transparent for us, and we can focus on the business logic and have our application support push technology. So with that, we will conclude the session and open it up for questions and comments from the audience. So feel free to type in your questions, and as we get them, we'll try to respond to them.
Hi Manoj, you have the questions in your questions window?
Yes, I do. So the question which Amit Garg asked is how SignalR treat differently between real-time versus delayed ticker data updates.
So the quick response to that is that SignalR, this is an application decision. SignalR is infrastructure. Your application needs to, your application will determine whether you want to send it throttled or delayed. If you're trying to ask if SignalR will give me capabilities to throttle or collate, to collate some of the ticker prices, then the answer to that would be no.
Yeah, that's primarily an application logic, right? Whether to implement a real-time price versus a delayed price is something that you need to implement on the server side. All SignalR will give you a push-based mechanism, whether you want to push the data to multiple clients or to a single client or to a group of clients. To have the delayed versus the real-time, it's something that you need to figure out in your application logic. All right, the next question is from Sherry. What would be the best way to learn about SignalR?
Well, so if you go to the official SignalR, just Google for SignalR-ASP.NET, and the official website has a lot of very good documentation. Actually, this project actually started off as an open source project, and it is hosted on GitHub. But the documentation is really good, and there is a lot of getting started and tutorial kind of material out there which will help you get started. Having said that, this is very new in terms of in terms of the technology itself. So the community is still finding out, still experimenting and finding out best ways of doing certain things and so on. Manoj, do you want to add to that?
Yeah, there are some good videos on channel 9 as well, so you can listen those. And yeah, but as Manish said, so the asp.net/SignalR is the website where you can go and find the real cool documentation. So the next question from Ramakrishnan is, what does R stand for in SignalR? I really don't have any idea about it. What does that R mean?
Hey, it's just a jazzy name.
Right. I guess. So there's another question from Ramakrishnan is, where do we have the control over the persistent connections? Right. So the persistent connections, most of the time, you don't have to deal with persistent connection. Though in case, suppose you want to deal with it, so there is a class by the name of persistent connection in SignalR namespace, which you can have your connection inherit from persistent connection. There are a couple of methods like on connect, on disconnect, on send message,
on
reconnect. So you can use those methods to have a connection mechanism, or basically if you really want to do something with that of connection management.
Actually, there is a lot of documentation around the, so Manoj mentioned the on connect, on disconnect, on reconnect kind of methods. It is instructive to actually read up on those, because the connection lifetimes, the way it is managed by SignalR, it is not immediately intuitive, the sequence in which those events happen. So you can have a client call on connect and then on reconnect after that without even disconnecting. As a matter of fact, if an on disconnect has been called, then an on reconnect cannot be called, because in terms of a persistent connection, these methods actually are representing the state of the underlying physical connection. So when on connect gets called, there's a physical connection that is established, and then the physical connection itself may break, but SignalR and the client side, the server side and the client side keep trying to reestablish that connection, and that is where the on reconnect gets called. When if the server and the client are not able to establish that connection, the physical connection again, and it times out either on the server or on the client side, then the on disconnect gets called. So it is not very intuitive that I just connected and I got an on reconnect without even disconnecting. So yeah, it is. It will be useful if you understand how the connection establishment logic works. Although you will not have to deal with it very often. In certain special scenarios you may, and that is why you should know about it.
All right, so the next question from Parminder is, can we incorporate SignalR in Visual Studio 2010? So this SignalR is basically based upon .NET 4.0 and 4.5, because it uses a lot of async await pattern, and it is primarily developed on .NET 4.0 and 4.5. I don't know. I don't think so. It is incorporated in Visual Studio 2010. We have to use.
Well, we haven't tried really.
Yeah, we haven't tried it.
Yeah.
But I don't know. I don't know the answer actually.
Yeah. It might work. I mean, because it uses .NET 4.0, but we haven't tried in 2010, to be honest.
So next question from Ganesh is, how different is this compared with JMS?
So it is hard to draw a comparison. JMS is a messaging mechanism over.
I guess we said that. So basically, JMS works with thick client application well.
Right. I mean, and it is meant for a messaging system.
Right.
You know, whereas here the concept is more an RPC based system. See, if you were dealing with only the persistent connection layer, then you would think of comparing it with the JMS, right? On the connection, you send a message from one end to the other, and the other end responds with a message back. When you're dealing with the hub, you're not thinking in terms of messages. You're thinking in terms of method calls. So this is the method I call on the server, and this is the method I call on the client. So I don't know if I answered that question, but you know, it is, you know, that is how you should think of.
Yeah, I guess it's very easy to get confused with SignalR as a messaging technology. It is not a messaging technology at all. It is just a way to publish the updates from server to client. That's all it is. It's not a messaging technology. It does not have all the flexibility that any messaging technology has. So you can use the JMS as a backplane for the SignalR, so that you have the persistent connections and basically you have the messaging capabilities with your SignalR message.
And which is why we showed the second example where we did a post request. You know, so the messaging technology that we were using there was still HTTP, right? And so that was the distinction we were trying to bring out, that you will continue to use your, you know, your regular messaging, which is HTTP based, but when you want to push data from the server to the client, that is where SignalR comes in.
The next question from Tabrez is, what's the difference between TCP and SignalR?
So SignalR is not a protocol.
Yeah.
In one line, SignalR is an abstraction over several mechanisms that are available to push data over the web to clients. It has nothing to do with a specific protocol.
There is a similar question from Subhash. If SignalR and WebSocket classes are same or any difference between them?
No, they're not. So SignalR and WebSockets is not the same thing. WebSockets is one of the underlying technologies that SignalR tries to abstract out. As I said, there are 4 or 5 different ways in which you can do, you can push data from the server to the client. Long polling being one of them. Timer-based polling on the client side and sending continuous requests is being another. Server-side events being another. Forever frames being another, and WebSockets being the newest one. So SignalR is an abstraction over all of these, and it is not WebSockets. It tries to use WebSockets as that is the latest and the latest and greatest, and that is what is recommended, but it is not WebSockets.
Another question from Dheeraj is, what is the difference in AJAX and SignalR, because both used for push perspective. So AJAX is not used for push perspective, right? AJAX calls are basically a timer-based mechanism. You periodically on a timer keeps on pulling the data from a server. You keep on asking server whether you have data, whether you have data, whether you have data. It's not that it's not that when the data is there with the server, it tries to push to the server, try to push to the client. That's where the SignalR comes into picture, whereas AJAX is basically a client-side technology. It keeps on polling the server. Next question from Kobilor is, have you used SignalR in SharePoint? If so, what are the challenges? No, we have not used SignalR in SharePoint, but if you are using SharePoint web parts, I don't see any challenge. It's just like a normal .NET controls, and you can very well use SignalR with SharePoint, because as far as I know, I've done development with SharePoint. I don't see a challenge there. It's just a normal .NET stuff. But I have not tried it, so Another question from Pradeep is, what about security in SignalR?
So that's security is a whole topic in itself that we could talk about at length. In short, SignalR uses the authentication of your web layer. It does not provide a separate authentication layer in itself. For authorization, it provides certain mechanisms for role-based and group-based authorization, which are essentially implemented in the form of attributes on server methods. That in a nutshell is what what the security support is. There are obviously nuances and specific scenarios and special security protocols that we can that should be a part of this answer, but I don't think we have the time for going into all of those. But that is what it is in a nutshell. You can, at high level, you can think of it as you will have to deal with security mostly on your own, the way you used to do it in a normal web application. And there are certain authorization related features available from SignalR. Do you want to answer?
Yeah, in SignalR, so in SignalR 1.1, it's really a gray area, right? So there is nothing much related to the security. But in .NET, in SignalR 2.0, they're coming up with OAuth support. So basically, you can use OAuth for your authorization and those kind of things. But yeah, as Manish mentioned, mostly that your application has to deal with it. Out of the box, there is nothing. The next question from Manas is, can SignalR integrated with DB2? So SignalR is basically a server-side push-based mechanism. So yeah, I mean, there's no
DB2 as in the database?
Yeah, DB2 as in database.
So yeah, I mean, it can. So it has nothing to do with which database you use. If you're asking in terms of the backplane, whether you can store state in the backplane in DB2, I'm not sure what this question means really. I mean, if your application can save data in DB2 and use that data to push it to the client, then that is what it is.
Yeah. The next question from Muthuraj is there anything similar to SignalR in Java, as SignalR is a Microsoft base? Yeah, so SignalR is Microsoft wrapper, is a Microsoft library. In Java, I don't know whether there is similar library or not. But there are a lot of, so the WebSocket support is there in a lot of Java-based servers like Jetty, and Node.js also has a support for long pole and support for WebSockets.
Yeah, I mean, I have seen support for almost all the underlying standards in several Java products, but I am not sure if this kind of an abstraction layer is implemented by any product. I am also not aware of similar. But all the underlying technologies are obviously supported by most Java servers.
So the next question from Pawan is, does SignalR can be hosted run on Windows 7? Yes, pretty much. So what we are demoing from is a Windows 7 machine. So yeah, just that Windows 7 does not have a support for WebSockets, but then it fallbacks to rest of the protocol. So yeah.
So yeah, I mean, if you are trying to use WebSockets, then you would need something higher than Windows 7. Otherwise, as SignalR itself can be used.
Next question from Kedar is, can SignalR be used inside a Silverlight app?
Yes, there is. There was a Silverlight to SignalR bridge or something like that. I looked at, but I'm not sure. I think it's some kind of an open source effort going out there.
Maybe I've not looked.
Yeah, I mean, the answer is that we don't know for sure.
Yeah. Next question from Anil is how scaling differs when using SignalR. So it's interesting, right? So scaling on SignalR is different from your normal web application scaling, because in normal web application scaling, what you do is basically you create multiple instances of your web farm or your web servers and then put a load balancer in front of those web servers. Whereas in SignalR, what you do is, as Manish mentioned in his presentation, there is a concept of a backplane. So all your SignalR servers, there is no a load balancer in front, but all the SignalR server, what it does is basically sends the message to the backplane server, and then that backplane server will post the message back to all the servers, and then it gets pushed to all the clients. So yeah, it's different than normal web server scaling.
Yeah, I mean, so scaling, as I mentioned on the backplane slide also, scaling is different because you need to think of concurrency differently. And you need to think about sharing the state, or a response, a broadcast, for example, needs to be shared across all the servers. In concurrency is different because you are maintaining persistent connections. So you may not be able to support such a large number of users because you have to maintain those open connections. Versus in a normal web application, you'll just open a connection, process the request, and close it.
All right. So the next question again from Anil is how use it in Windows-based application with VB.NET.
You want to take that?
Yeah. So I don't see a reason why you cannot use it in VB.NET. It's a .NET application which is
basically asking about the client. So there is, similar to the JavaScript, the JavaScript libraries, there are some client .NET libraries available also. So you can have a SignalR server and you can write a web application against it using the JavaScript set of libraries, and you can write a VB.NET application using the .NET library. So yes, you can use it in a .NET thick client application also, if that was the intent of the question. The server, obviously, all the demos we did were .NET applications.
Next question from Ravindran is, can this be programmed using VB.NET, or do we have to use only C#?
We just answered.
Yeah, the same. Yeah. So basically, both server and client, you can have VB.NET and use the SignalR bits. So it's MSIL code, so you can use it. Okay, I think that's pretty much all the questions we have.
All right. So thank you everyone for your time. I hope this the information we provided was useful to you. All right, thank you.
Yeah, thanks for the insightful presentation, Manish and Manoj. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by tomorrow. Thank you all. Thank you, Manoj and Manish, once again. Have a great day.
Thank you. Bye-bye.